today it's going to be shapes in general. In the next about 3 or 4 days, we're going to switch over to just dealing with congruent triangles. Okay, that's the main focus of the entire class. Okay, so, to start, we'd assume, right, we've done congruency before, that most people have the general idea of what congruent means, right? And what does it mean? What's congruent mean? What does it mean? Someone. So what? They're the same. Right. That's all you need to know, right? They're the same. Now, to be a little more technical, since I said, right, we're dealing with congruent shapes, right, and in particular triangles, for the stuff you're doing today, that would be the definition of congruent polygons, which also tells you what you need to show in order to say that they're congruent. Okay, so the definition is actually telling you how to do like half the problems today. Well, maybe not half, but some of the problems. Okay, so again, polygons, right? Polygons are just shapes with straight sides, right? No gaps in it. I don't have any curved sides, no circles, or nothing like that. The word corresponding, remember, came up in the last chapter, right? With the angle pairs, we had corresponding angles there. This is a little different, but I said, in general, if you ever see the word corresponding, remember it means in the same spot. So like when I say corresponding sides, that means if you took two shapes and stacked them on top of each other, like so they line up pretty good, that the corresponding sides would be the overlapping sides and the corresponding angles would be overlapping angles. And that's the key to being able to do these promptly. You have to identify those parts in order to do anything dealing with congruence. Okay? So, you start with, before I do anything with congruency, alright, I'm going to take those two shapes, we're going to make a list of all the corresponding parts. And like I already said, I've got it written out also, the corresponding parts are simply going to be the ones that overlap. If you took the two triangles and stacked them on top of each other, in this case triangles, it could be any shape. Alright, and again, when it's stacking, this doesn't mean take them and put them over top of each other. You want to line them up so that longest side and longest side are overlapping. Smallest and smallest and so on and so on. Okay? And any problem that you guys do today that says something like, are these shapes congruent? I would expect everything that I'm about to put up there to be this. Okay? So I'm going to write out the corresponding parts first, which would be, I'm going to write out all the corresponding sides over here. And then I'll do the corresponding angles right there. Alright, and eventually what we'll do is I'm going to list them out, then I'll show you that this is how you show that these things are congruent. Alright, so corresponding sides. I'm going to start with side D. Okay? Alright, so I'm not doing any property with it or anything. Okay, so all I'm asking you to do is match them up. I don't want to know if they're congruent or not yet. Alright, so if I asked you, I said, you know, here's side DE, which side over in this triangle do you think corresponds to? Alright. Okay, so right there, there would be one there. Again, I'm not doing anything with it yet, I'm just simply practicing matching these things up. Next one we'll do F. Which one do you think corresponds to FE?
FC.
C. And in here it should be a little easier because it's already marked off. If they don't have the markings on, guys, like I said, just try and go like smallest side to smallest side, biggest side to biggest, middle, so on and so on. All right, but then I do DF, DF, and what's the other? Okay. So this would be on the corresponding sides. Then the corresponding angles would be like angle F. Which one corresponds to F?
D.
R and
D.
D.
E and then E and F. Okay. Now, if the problem progressed from there, they said, okay, now you got all the corresponding parts listed out. They said, look, these two shapes, are these congruent to each other? Even if I don't ask you to do this, but I give you two shapes, particularly shapes that aren't triangles in the coming days. And I said, look, are these shapes congruent to each other? Like, is this shape the exact same size as this one? I expect all of this to be listed out because you have to check every single pair of these to see if these two are congruent to each other. All right? And this entails mostly to shapes that aren't triangles. Okay? So you would just go down. If any single one of these pairs is a no, then this would be a no answer. Every single one of these has to be yes for this to be a yes answer for congruent. All right? So looking at the way they're marked, I mean, the D, E, and R, so those congruent? Are they? Yeah. Are these congruent?
Yeah.
Yeah, with the,
Yeah.
not these two.
Yeah.
So this would be a yes. All right? Like I said, if any of those ends up being no, even just one of them, you get a no answer. But I have it that you only have one pair of these messed up. Okay, now, the next part that comes, you guys are going to be writing a thing called a congruency statement. Okay, so as it goes, you do corresponding parts, okay, and then you use the corresponding parts to say whether they're congruent, all right? And then in general, if I ask you this question, I'm going to say if they are congruent, which these are, I want you to write out things called a congruency statement, all right? All that is, congruency statement. It's a statement saying what things are congruent. That's why they put those words together. There aren't really any tricky words. Okay, it's pretty straightforward. Now, so in this case, right, it's two triangles. So I'm going to be saying like the triangle on the left is congruent to the triangle on the right, like that. But I want to use letters for this. When you name these triangles, remember I talked about it a little bit in the past, right? When you name triangles, you name it by the points on the triangle, like the vertices. So like this triangle over here, I can call triangle, I don't know, what do you want me to call this one? What order do you want the letters to go in? FBD?
Yeah.
All right, so if I do that, and I want to write a proper congruency statement, meaning I want to say this triangle is congruent to this one, right? Congruent, and then the other triangle. The order of the first one doesn't matter. That's up to you. The order of the second one has to match up in corresponding order. Such as F is the first letter here. The first letter on my second one has to be the angle that corresponded to F. So that was T. Middle one has to be the one that corresponds to E, which is S, and then D, and R. Okay, so the order of the first one doesn't matter. Like if I would have started this triangle PDF, that means if I write a proper congruency statement, what would come after would be S, because that corresponded to E, right? R, because that's corresponded to D, and then E. So those would both be correct. And like the reason having these in order is simply so if I show you a congruency statement, even without seeing the picture, I know which angles are congruent to each other. I'll know which sides are congruent to each other simply based on the statement. Like if I took a like four-sided figure, if I said, you know, you had A, B, C, D, I don't know what kind of shape it is, quadrilateral. If I said A, B, C, D was congruent to E, F, G, H, even without having the picture there, I know that angle C is congruent to angle G. I don't know how big it is, but I know they're equal. Okay? I know angle A and angle E are equal. I know that side AB is congruent to side EF. A congruency statement has to be in the right order because it gets used in that manner. Like you use it to show which parts are equal without even seeing the picture. That tells you how to set up problems. Okay, like where you solve for variables and find the side lengths, that kind of thing. Okay, now, so the way you would use it, this would be a problem where you're using like a congruency statement in corresponding parts. And with the two up there, we'll do like triangle YXZ, congruency triangle. It really doesn't matter. Which order do you want the other one to go in? SRT. Okay. The reason it doesn't matter is because I don't really have a set answer for A and B. I just want to show you how to match them up. So a problem like this, I would say, okay, this is given to you. Like it's a known fact. I'm telling you these two are congruent. That's the congruency statement, which in turn means that I know Y and S correspond, X and R, Z and T, those all correspond to each other. All right, so all it would do is this would be a problem where it's like, find the value of A and B. Okay? So a problem like this where you've got like A and B on the actual angles, that just means matching corresponding angles, you're going to have an equation. So just based on this one, okay, if I go to A is on this angle right here, correct? Right there. Agree? If I go back to the congruency statement, Y is the first letter. First letter over here. So those two have to be equal according to the congruency statement. So I know 4A minus 4 equals 48. Okay? And all that information just came from here. Don't go with necessarily how these look if they give you a congruency statement. Stick with the statement. All right, so that'd be 4A, is that much?
52.
52, and then 15 divided by 4 is
13.
All right, and then for the B1, B is up here at Z. 5B minus 3. Z is the last letter. It's the last letter here.
13.
2. 5B equals how much? 5B is
13.
okay. So main idea of that: make sure the order is matching. If it's not, screw problems up completely. You know, to help anyone out. Okay. Now, some stuff I want to add to that paper, guys. Okay. I'm only going to go through two things that I want you to put on there. Obviously, you can put whatever you want on that paper, but I'm only going to highlight a few things that come up over and over again. Okay. And what I have, this is going to be like where I expected with the common figures for congruent triangles. That area. What I'm doing is I'm going to give you kind of like diagrams, like real common diagrams that get used over and over and over and over again in these problems. I'm going to point out things that you need to mark congruent. Because again, the idea of congruent shapes is that you have pairs of sides and pairs of angles be equal to each other. And like half of it is going to be based on what it looks like. All right, I'm only going to give you two like diagram things to put down today. And the way I'm going to do it is I'll have them numbered, just like any list. And then right next to it, I'm going to give you like the reason, because again, you need to think in terms of statements and reasons. Statements, this side right now is where you're saying what things are congruent, or what you're using to get it. Reasons, again, are always your theorems, your definitions, all that stuff. So what I'm giving you guys right next to the number, at least for these two today, is going to be a reason. So this first one's going to be vertical angles being congruent. Okay, so again, think in terms of a proof, right? This is your reasoning or an explanation. All right, and then the picture is always given to you guys, but I'll write the statement beside it. Okay, so vertical angles, the way this will pop up, focusing mostly on triangles, this is where these will come up today, would be any kind of triangles where they're kind of like facing each other, facing like a little bow tie shape kind of thing. So this would be those two triangles. All right, and again, this would be questions like, is this triangle congruent to that one? That kind of thing. And this is just giving you at least one step that you can put in your proof outside of the given. Givens will be whatever they give marked. This would be something that they're never going to mark, because it's just a known fact that if you've got two triangles formed in this manner, those two angles are congruent, because they're vertical angles. If you need anything new, it's just in the context of like putting them in triangles, sometimes people flip out. Okay? One thing that usually helps with this stuff right here, so again, is numbering the angles. It just simplifies writing it out. So this would be like your statement part that you're reading. Pictures are given to you always. Yeah. Right. No, the top section leaves because that's going to be the instructional. The 4 ways thing. That's what we're starting tomorrow. Okay. And this is pretty much the only place you're going to see the vertical angle. Okay. So I expect, like anytime I give you a problem, even if you cannot complete the proof, if I have a picture that looks like this, I expect everyone to be able to say those 2 angles are congruent with the vertical angle. Even if you don't have a complete proof, you can at least have one step. All right? Anything that's on that sheet, I expect you to have correct. Okay, the second thing that I'll ask you to put on there, this is reflexive property. Again, I'm right here. I'm putting the reasoning. It's of congruency because we're talking about congruent angles and congruent sides, not equal ones. Even though the words mean the same thing. So again, this is a reason, right? It's thinking in terms of statements and reasons. All right, there's probably about, I don't know, 3 or 4 I'll put here. Usually with you guys, the reflexive property thing is going to be reserved for 2 sides being used. All right, not necessarily angles. There's like one situation where angles might pop up, but usually this is for side length. Real common one, let's see. This would be a picture you guys will see like this, where it would be the 2 triangles you'd be comparing would be this triangle and this one. Like they'd be asking, are these 2 triangles congruent? All right. And so what you got with reflexive, guys, is just an overlapping side. A side that is the exact same side in both triangles. Like BD. This side right here is part of this triangle, and it's part of that triangle. So it's technically a pair because it's in both of them, but it is the exact same thing. So you would write something like that as a statement, your reason would be reflexive. Because you got to remember, the whole idea of this stuff is you want to find pairs of angles that are congruent and pairs of sides that are congruent from one shape to the other. Another one. Be more like a diamond shape. You see this one a few times. Again, lettering is the same. It's still BD, BD, and equals. There was one of the ones from the warm-up had a reflexive on it. One with like a parallelogram, you know what it is. It's kind of already covered up there. All right, there's one other one I definitely want you to draw down. Okay, now you can start it with that. Now this one is usually one people kind of get messed up on. And just don't add this other triangle yet. I'm just trying to tell you a little bit how this is. All right, so the idea is they're taking these 2 triangles and they'll ask you to do them congruent. The thing is, this triangle will be slid over on top of it. So if I just took this and slid it right over so that it was fully overlapping, you would have a shape that looks something like this. Okay, and when they slide them over, right, a lot of times people get lost on which triangles they're looking at. All right, but remember it was this big one and the other big one. So what happens is this bottom part is in both of the triangles. So if I use the same lettering so you don't have to change the statement. All right, and the reason this gets confusing for some people is there's other little triangles up there you might think you're working with, but you aren't. Usually with ones like this, they're not even going to have that point labeled unless it's needed. So if that point's not labeled, you just forget about it. Like, don't even worry about it. Because it's not part of the triangle, so it doesn't matter. Okay? And if you wanted to add the little picture for the angles, because all this stuff is silent. Majority of the time, reflexive property is going to be silent. If you see something that kind of looks like this angle up here, is a reflexive angle. This is the only time you'll see, like, for reflexive property, this is the only time, let's say today, you'll have something like that. Doesn't come up that often, you know, you might see it sometimes. So I'd be more concerned with these right here, trying to get those ingrained in your head. Okay. All right. One last thing, and I don't care where you add this, you can add it somewhere on the paper, it's already out, back in the next, whatever. It's a theorem, but it's a theorem that you're only going to really focus on today. Okay. I'm going to write it out more or less with pictures than anything else. It's easier to see that way. Third angles theorem deals with you having two triangles. Okay? And I'm going to write this, like I said, with pictures. So like the hypothesis is I'm just going to draw it out. All right, so if you've got two triangles, ABC, then what three letters are you using? What? Okay, so like if I had two triangles and it was known, or I did the work to get like A and Z being congruent and B and Y being congruent. If that's a known fact, all this theorem says is that if you already know that, then C is congruent with that. It gives you kind of a quick workaround with saying these two are congruent. So the if part, the hypothesis would have to be something like that, where you've got two pairs. The third angle just lets you do the third. Now it's only going to apply to today, mostly because today you guys are doing congruency with the definition, meaning like all pairs are congruent. Okay, by definition. But beyond this day, we're only going to, you don't need all three. Okay, because at the end of the day, we need all three pairs of angles to say the two triangles are congruent, and all three pairs of sides. Okay, and that's all that theorem says. So if you ever run into something where you say, oh, two pairs are congruent, the third pair has to be, this is your reason why. Okay, like that would be your statement, that would be your reason. Okay, the conclusion part is always your statement if you can figure it out, and the name of it is always the reason. You know, when we're dealing with it. All right. Is there anything I need to go back to? Good. Okay. Make sure, guys, that